So, all right, guys. Good evening to all. So, now you people are programmers, right? Now you can write program on your own. So, we have seen what is meant by variables. We have discussed about operators. We are currently discussing operators, right? We haven't completed the topic yet. So, yes, now I am going to disable the chat section. After completion of this session, I will enable it once again so that I can clear your doubts. So, yes, now I am going to create a new folder here named day 4. So this is our for today, right? So inside this folder, I am going to open our Visual Studio Code software. So yes, you can see here, I have just opened my VS Code, and here I am going to create a new file named logical operators, logical operators.py. Let me zoom in a little bit, and I am going to select my Python interpreter, which is 3.11.4. So everything is fine. And also, I want to open our GitHub link. So I'll do that in a new tab. So as you can see here, so in our yesterday session, which is day 3, we have discussed about data types, and we have seen what are assignment operators, and we have also seen what are arithmetic operators, right? We have completed assignment operators and arithmetic operators. So the remaining operators are comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So in today's session, we are going to discuss about all these remaining operators. Yes, without wasting time, let's get started. So before discussing about logical operators, we need to discuss about comparison operators, right? So here I'm going to create another file named as comparison operators.py. So yes, now of course our first thing is now here we are going to discuss about comparison operators, and these comparison operators are used to compare two variables. So let us see that how we can do that. So first here I am going to declare a variable named A, and let me assign value of 10 to this variable. And similarly, I am going to declare another variable named B, and let me assign value of 15 to this variable B. Okay, fine. Now we have got two variables A and B whose values are 10 and 15. So what are these comparison operators? As I already told you, these comparison operators are used to compare two variables. So the first comparison operator is greater than. And we know the symbol of greater than is this one. So we all know the symbol of greater than, you can see here. So here I am going to, so if I say print A greater than B, then can anyone guess the output? So yes, the output will be A. So here we are checking whether A is greater than B or not. And we know that the value of A is 10 and B is 15. So is 10 greater than 15? False, right? So if I run this program, then you can see here I got output as false. So here you can see my output is false. So similarly, if I say the next logical operator is less than, and we know the symbol of less than is this one. So if I say print A less than B, and if I run this program once again, you can see here first I got false and after that I got true. Because for the line number 5, I am getting output as false, and for line number 8, I am getting output as true. Because we know that 10 is less than 15, so I got output as true. So you can remember one more thing here. So the output of these comparison operators is always Boolean value. So in our previous class, we have discussed about arithmetic operators, right? So if we perform arithmetic operation, then our output is integer. Whereas in case of comparison operators, if we perform if we use comparison operators, then we will get output as Boolean value. So our output will be either true or false. That's it. We won't get any other value than true or false. We only get either true or false. So this is one more thing which you should remember while using comparison operators. So once again, let me repeat: these comparison operators are used to compare two variables, and also there is one more thing. So here you can see this A greater than B, and similarly A less than B. All these things are conditional statements. We call these things as conditional statements. So remember this term conditional statements. This A is less than B and A is greater than B. All these things are called as conditional statements. Let me mention over here conditional statements. So our next comparison operator is greater than or equal to, and is represented like this. So here, let me declare new variables here as x. So the value of x is 15 and the value of y is also 15. So if I say print x is greater than or equal to y, then what will I get as output? Let me run this program. So and also I will comment line number 8 and line number 5 so that you won't get any confusion. Let me move this upwards. If I run this program now, and you can see I got output as true because obviously the value of x is 15 and the value of y is also 15. So 15 is greater than or equal to 15. So we will get output as true. Similarly, if I say print x is less than or equal to y, then if I run this program once again, then you can see again I got output as true because 15 is less than or equal to 15. So 15 is equal to 15, right? So we are getting output as true. So what happens if I change the value of y to 10? So let us check here. So for line number 14, so for line yes, you people can clearly hear me, right? I have enabled the chat section. You can let me know. And also there is no lag in my screen, right? I just want to confirm once again. So Abhishek says video struck. Screen invisible. Just please let me confirm once whether my screen is clearly visible or not. So audio is very low. So frame okay, fine. Just give me a second. I'll check once again. Okay, fine. So yes, guys. So let us continue. So here. Now I think you can see my screen. Okay, fine. So we are discussing about these operators less than or equal to and greater than equal to, right? So this operator is less than or equal to. Okay, if you feel any lag in the frame of screen, just cooperate with me for one more day. From Saturday onwards, I'm going to make sure that you won't feel any kind of issues because I'm changing my location. So right now I'm in Bangalore. So I'll be moving to my native place on Saturday. So from Saturday onwards, you won't face any kind of issues. I'm going to assure you that. So just bear with me for for one more day. So tomorrow is the last day. So okay, fine. So we have completed discussion about greater than or equal to and less than or equal to, right? So yes. So here now I have changed the value of y to 10. So now what will be the output of line number 14? So is 15 greater than or equal to 10? Yes, true. So for line number 14, I will get output as true. So similarly, is 15 less than or equal to 10? No, right? 15 is greater, not less. So I will get output as false. So if I run this program, then you can see here for line number 14, I got output as true, and for line number 17, I got output as false. So yes, this is the thing. So I hope these are simple concepts only, so you can understand this easily and quickly. So these are like basics only. So we have seen the next comparison operator is equal to, and it is represented like this. We need to use equal to symbol two times. So now here, let me declare a new variable called n1 and let me assign value as 20 to this variable n1, and again I will declare a new variable called n2 and the value of n2 is 15. Now if I say print n1 equal to n2 and I run this program, I can say I got output as false because the value of n1 is not equal to n2. Here the value of n1 is 20 and the value of n2 is 15. So I can see in my other device the screen is not changing at all. Okay. So yes, the presentation is lagging. So let me stop this presentation and present once again. And now I have shared my screen once again. So, okay. Some are saying that no problem here. Okay, fine. I'll continue now. So now I think you're not feeling any lag in the screen. So fine. So here you can see here from line number 19. So I have declared two variables n1 and n2. The value of n1 is 20 and the value of n2 is 15. Now here I am printing. I'm here checking whether n1 is equal to n2 or not. So here if I run this program, then you can see here I got output as false because the value of n1 is 20 and n2 is 15. 20 is not equal to 15, so I got output as false. Similarly, if I change the value of n2 to 20 now, and if I run this program, then you can see here I got output as true because 20 is equal to 20, right? So yes, let me move this upwards. So our last comparison operator is not equal to. So it is represented like this. First, we need to mention a accelerated mark followed by equal to symbol. This is how we mention not equal to. So now here, if I say print A not equal to B, and if I run this program once again, then you can see here I got output as true. So it is not true. So I'm sorry, I'm using variables n1 and n2 here. If I run this program again, then we can see here I got output as false because the value of n1 is 20 and n2 is also 20. 20 is equal to 20. So here in the line number 25, I am saying that 20 is not equal to 20. So I got output as false. Now, if I change the value of n1 to 21, then obviously I am going to get output as true because 20 is not equal to 21. So these are the comparison operators available in Python. So these are basic mathematical operations which we have performed in our childhood. Right? So we are using greater than symbol here, less than, greater than or equal to, less than or equal to, and equal to. These double equal to operator is used to check whether the two variables have same value or not. So similarly, we have not equal to. This is complete opposite of equal to operator. So these are all the comparison operators available in Python. And you know, so here I am going to say operator in Python. So let me open any one website. So we are discussing about comparison operators, right? You can see here. So these are the comparison operators available in Python, and we have discussed about all these operators right now. So you need to remember this equal operator. So where it is represented using two equal to symbols, and a not equal operator, which is represented using exclamatory mark followed by a equal symbol. So you should remember these comparison operators. So after completion of comparison operators, our next topic is logical operators. So I've already told you that in the beginning of the meeting. So this is a statement. So n1 is not equal to n2. This is a conditional statement. A is less than b. This is also a conditional statement. Similarly, a is greater than b. It is also a conditional statement. These things are conditional statements. We call them as conditional statements. You can see here I have mentioned that in line number 9. So now let us discuss about logical operators. I have created a new file here called the logicaloperators.py. So in the beginning of our session, I have created this file. So yes, now let me give heading here as logical operators. So there are three logical operators available in Python. So what are those logical operators? Let me explain. So the first logical operator is and. So our first logical operator is and. So what this operator will do means if both conditions are true, then and operator will return true. So yes, so the AND operator, the first logical operator is AND operator. So here the thing is, if both conditions are true, then the AND operator will return output as true. So we know that comparison of the output of comparison operators is a Boolean value. You can see here we got output as only either true or false. Similarly, the output of logical operators are also either true or false. So let me explain you about the first logical operator, which is AND. So this operator will return true if both conditions are true. So here the thing is, let me declare here a variable named A with value 10, and again one more variable named B with value 15. So I know that if I say print A greater than B, then I can see here I got output as false because 10 is not greater than 15. So I got output as false. Similarly, if I say print A is less than B, then I got output as true because 10 is less than 15. We know this. These two are logic comparison operators. Right? So now what this logical operator will do? So here if I say print, so let me assign the output of logical operator to a new variable. So here I will say and output. So here my variable name is and output. I can give variable names as my choice. Below that, right? So here I am saying A is greater than B and A is less than B. So you can see here, these logical operators are used to compare two conditions. So here I am comparing two conditions, A is greater than B and A is less than B. So if both conditions are returning true means, then the output of this AND operation will be true. If any one condition is returning false means, then my output will be false. So to get the output as true, I need to let me comment line number 8 and 9. And if I run this program, I need to print the value of the variable and output. If I run this program, you can see here I got output as false. It's just I need to make sure once again I've enabled the chat section. Is my video frame still lagging? No, right? You can clearly hear my audio and there's no problem in video, right? Bhavya and Bhavya are saying no. So Pawan is saying little bit. Okay. Okay. Okay, you are saying no problem. So I'll continue with our class. So what is line number 10? Okay, fine. I'll explain this once again, line number 10. So here the thing is I have declared a variable named output and this name is my choice. It's my own choice. And the next thing is I am comparing two conditions here. So here my first condition is A is greater than B and my second condition is A is less than B. So for comparing two conditions, we use logical operators. Our first logical operator is and these logical operators will return Boolean values as result. So here the thing is, if the both conditions are true, so the conditions which are present on the left side of the AND operator and the condition which is present after on the right side of the AND operator, if these two conditions are true means, then I will get output as true. Otherwise, I will get output as false. So here, if I run this program, I can see here I got output as false because A is here the first condition is A is greater than B in line number 10. So we know that 10 is not greater than 15. So here I am for first condition I will get output as false. And for second condition, which is A is less than B, I will get output as true. So false and true is false only. So here in the line number 11, when I am printing the value of and output, I got output as false. So for clearly understanding, let me comment line number 11. Here I say print true and true. Means false and false. Print true and false. And finally print false and true. Now if I run this program, then you can see here I got test true, false, false, false. So what does this mean? Here I am using AND operator. So if true and true is true, and remaining all conditions, I will get output as false. So if any one condition is failing, then I will get output as false. So here the main thing is in logical operators, we use these logical operators to compare two conditions. So if the output of both conditions are true, then I will get the result of logical operator is also true. If output of any one condition is false, means then I will get output as false. So this is what happening here. So here I will comment this 4 lines also, and here if I say print, let me say here my first condition is 10 is greater than 5, which is true, followed by the next condition is 15 is greater than 10. So here both conditions are true. So if I run this program, then you can see here I got output as true because 10 is greater than 5. This condition is also true, and 15 is greater than 10. This condition is also true. So I got output as a final output as true in logical operation. So if I say print, if I change these values like this, if I say 10 is less than 5 and 15 is greater than 10. Now, if I run this program, then you can see here for line number 18, I got output as true. We know that. But for line number 19, I got output as false because 10 is not less than 5. So this condition is false. So if any one condition is false, means I will get output as false. So this is the thing about logical operators. You can check this in this website also here. For the AND operator will return true if both statements are true. You can see here. In case of line number 18, both statements are true. 10 is greater than 5 and 15 is greater than 10. So these both statements are true, and finally I got output as true. Whereas in line number 19, the first condition, which is 10 is less than 5, is false. And the second one is obviously true. But even one condition is failing here. So I got output as false. So this is the thing about AND logical operator. So I will comment these 2 lines, and the next logical operator is OR. So this OR logical operator is mentioned like this. We use OR in English like this. Small case. We need to use lowercase. Now here the main difference is in case of OR logical operator, if any one condition is true, means then I will get output as true. So let me show you with the help of the print statements. I am going to copy these 4 lines from line number 13 to line number 16, and I will uncomment this. Now here in the place of and I am going to change this as OR. If I run this program, then you can see here I got output as true, false, true, true. So what is happening here in line number 23, I am saying true or true. So if both the conditions are true, means I will get output as true. But in line number 24, I am saying false or false. Here both conditions are failing. So false or false is false. I will get output as false. Whereas in case of line number 25, I am saying true or false. Here one condition is true, the other condition is false. Even one condition is true, then I will get output as true in case of OR operator. Whereas in case of AND operator, I want both the conditions to be true. Then only I will get output as true. Whereas in case of OR operator, if any one condition is true, means I will get output as true. In line number 26, you can see here I am saying false or true. For this also I got output as true because here the second condition is true. So this is the thing about our operator. So I will comment these lines and let us check with our conditional statements. So here if I say print n is greater than 5 and 15 is greater than 25. And if I run this program, then you can see here I got out. I'm sorry, I need to use R here. So if I run this program now, then you can see here I got output as true. So what is happening here? 10 is greater than 5. Yes, the first condition is true. Now what is our second condition? 15 is greater than 25. So 15 is not greater than 25, right? This is false. But again, I got output as true. Because if any one condition is satisfied, or if any one condition is true, then I will get as true in OR operation. Whereas in case of AND operation, I want both the conditions to be true. So you can see here if I change this to AND, you can see here I got output as false. Now let me change this to OR once again. Now here if I say let me change this first condition to 10 is less than 5. Now if I run this program once again, then you can see here I got output as false because here both the conditions are failing. My first condition is 10 is less than 5. It is false, 10 is not less than 5. And my second condition is 15 is greater than 25. This is also false, right? 15 is not greater than 25. So here I am getting output as false. So this is the thing about OR operator. So our final logical operator is not operator. So it is represented like this. We need to say not in lowercase. So now here the thing is this not operator will also return output as Boolean value, but it will check only one condition. So let me explain this with an example. If I say print not of 10 is greater than 15. So is 10 greater than 15? I hope you all are following this. Just tell me whether 10 is greater than 15 or not. I have enabled the chat section. No, okay. Sekhar and Kavya are saying no. Satish is saying no. Okay, fine, it's fine. Okay, Davish also said no. Okay, fine. I have disabled the chat section. Okay. Okay, yes. So 10 is not greater than 15, right? Now, if I let me comment line number 28, and if I run this program, then for line number 32, I got output as true because we know that 10 is not greater than 15. So this will return false. If I print 10 is not greater than 15, then I will get output as false. But if I say not of 10 is greater than 15, then I will get output as true. So what is happening here? So here the thing is, if my condition is true, then I will get output as false. Vice versa. Or else if my condition is false, then I will get output as true. You can see here my condition is false. 10 is not greater than 15. Here my condition is false. So I am getting output as true. So I can explain it like this. So if I say print not of true and print not false. So let me comment line number 34. If I run this program once again, then you can see here for the line number 32, I got output as false. So not of true means I will get output as false, and not of false means I will get output as true. So here the main thing is if my condition is true, then I will get output as false. If my condition is false, then I will get my output as true. You can see here my condition here is false. So if I run this program once again, for line number 35, I got output as true. Now let me change this. Here I will say now 10 is less than 15. So 10 is less than 15, which is true, right? So if I run this program now, then you can see here I got output as false. So these are the three logical operators. The final one is not operator. So we have discussed these three logical operators and or not. I hope you all are clear with these three operators. So we have completed our discussion in comparison operators and logical operators. So our next operators are identity operators. Now let us discuss about these identity operators. Let me create a new file here. Identity operators.py. So let me give you a heading as identity operators. There are two identity operators available in Python. They are the first one is and the second one is not. So what are these operators? Let's discuss. So first here I will declare a variable A and I will assign value 10 to this variable. Again I will declare variable B and I will assign value 10 to this variable. So the value of A and B are same. You can take here if I say print A equal to B, then you can guess I will get output as true. We have this double equal to is a comparison operator. We know that we have discussed this here in the comparison operations files. We have discussed it here. So here the thing is, so if I say A equal to B, then I will get output as true because 10 is equal to 10. Now if I say A is B, if I run this program once again, just give me a second. So this is operator will return true if both the variables are pointing to a same memory location. So here the thing is, if both variables have their values stored in same memory location, then I will get output as true. So the of course we are not going to use these two operators. We will use logical operators in our program, and also we use comparison operators a lot in our program, but we don't use identity operators anywhere, so don't get confused about memory location thing. So let me explain quickly. So here, whenever I am assigning value to a variable, then that value will be stored somewhere in a memory location. So with the help of that only, I can able to view the result in output screen, right? So whenever I am assigning a value to a variable, then that value will be stored somewhere in a memory location. So whenever I call that for example, if I print the value of A, then my Python interpreter will fetch the value of A from any one memory location. So this is how internally the variables work. So whenever I am assigning any value to a variable, that value will be stored somewhere. That value will be stored somewhere in any one memory location. So here the thing is, if both the variables are stored in same memory location, then I will get output as true. If they are stored in different memory locations, then I will get output as false. So you can see here print A is C. Here I am saying A is C. I am the value I am assigning A to C variable here. I have declared a variable C and I am assigning value of A to C variable. So A and C, these two variables are pointing to same memory location. So if I print this, now I will get output as true. Similarly, if I say print A is not C, and if I run this program, then you can see here I got output as false. This is not operator is exact opposite of is operator. So that's the thing here. So these are two identity operators. What you need to remember is if both variables are pointing to same memory location, then we will get output as true in case of is operator. Whereas is not operator is total opposite of is operator. So what does that mean? If both variables are pointing to same memory location, then I will get output as false. You can say here, if I say A is not C, I got output as false because A and C, they both are pointing to same memory location. I am saying A is not C, so I got output as false. So is not is exact opposite of is operator. And we know that is operator will return true if both variables are pointing to same memory location. Now I have told you that what is memory location also, you don't need to confuse about that. So whenever I am assigning any value to a variable, that value will be stored inside some memory location. So this is how our variables in Python work. So our next operators are membership operators. Before discussing about membership operators, I think we need to complete the topic of list and tuples. So fine. After completion of list tuple sets, we will discuss about membership operators. In today's session, I am not going to discuss about these membership operators. We will discuss this in upcoming sessions. I won't forget. You don't have to worry about that. I will definitely teach this one membership operators. Now the last one is bitwise operators. Now here I am going to create a new file named bitwise operators. So what are these bitwise operators? So while programming real-time problems, I personally I have never used these bitwise operators and I never used these identity operators. So you don't have, if you are unable to understand about these two operators, then it's fine. You don't have to worry about this a lot. But I just want you to have some basic idea regarding these two operators, which are identity operators and bitwise operators. And here, if you want, you can check out the definition of identity operators also. So identity operators are used to compare the objects. So okay, here you have used the new terms like objects. If you don't know what is meant by object, it's fine. In our upcoming classes, we are going to discuss about classes and objects. So okay, fine. I hope the thing is in identity operators, just remember this. I'm repeating once again, don't get confused. In identity operators, I will get for each operator, I will get output as true if both variables are pointing to same memory location. For is not operator, I will get output as true if both variables are not pointing to same memory location. So that's the thing. So I will mention this here also. I don't want you to forget this. Is operator will return true if both variables are pointing to same memory location. So regarding is not operator will return true if both variables are not pointing to a same memory location. And that's you can say this is exact opposite of is operator. This is the thing about identity operators. Just remember this definition. If both variables are pointing to the same memory location, then I will get output as true in case of each operator. So let us continue with bitwise operators. So, so okay, fine. These bitwise operators perform operations in bit level. So you all know regarding binary numbers, right? So here our first bitwise operator is bitwise and it is represented with and symbol. And see here. So this the first thing you need to remember is bitwise operators perform operations in binary level. So and my first bitwise operator is bitwise and. So let me explain this with an example. Here I will assign value 3 to variable A and 2 to variable B. So I have two variables now. So first I want you all know how to convert a decimal number into binary number, right? So the binary form of 3 is 0011. So similarly, the binary form of 2 is 0010. So this is how we represent binary numbers. I guess you all know how to convert decimal number into binary number. I am not going to discuss about that because it will become a lengthy session. So what will happen now? Our first operator is bitwise 100. So here I perform AND operation when In case of AND operator, if both values are 1, then I will get output as 1. Otherwise, I will get output as 0. Let me repeat once again. In case of bitwise AND operator, if both values are ones, then I will get output as 1. Otherwise, I will get output as 0. This is similar to logical AND operator. In case of logical AND operator, we will get output as 2 if both conditions are true. Similarly, in case of bitwise operator, if both values are ones, then I will get output as 1. So here you can see the first thing. So 0, 0, I will get output as 0. 0, 0, again I will get output as 0. For 1, 1, I will get output as 1. And for 1 and 0, I will get output as 0. So I think you understood how this is working. So I need to perform AND operation in between the decimal numbers of 3 and 2. So if I perform AND operation, which means if both values are ones, then I will get output as 1. If any one value is 0, then I will definitely get output as 0. So this is the thing about bitwise AND operator. So what is 0010? It is 2. Now you can say if I print A and B, and if I run this program, then you can see here I got output as 2. And we know how 2 is coming here. We have seen here in line number 7, 8, 9, 10. We have seen how we got output as 2. I got output as 2 because uh, if both values are 1 in 3 in the decimal form of 3 and 2, then only I will get output as 1 in case of AND operation. So this is how bitwise AND operator will work. We are performing operations on bit level. We are performing operations on binary numbers. So first we need to convert decimal number to binary number, and in binary numbers we will perform operations. So the next thing is, let me comment line number 11, and let me move these two upwards. I know that the value of A is 3 and the value of B is 2, and our next bitwise operator is bitwise OR. It is represented like this. We need to use this symbol for bitwise OR operator. So you can find this symbol above your enter key in the keyboard. Up on the above enter key, you will find this symbol. You need to press shift and the key which is present above your enter key, then you will find this OR operator symbol. So how this will work? Let me copy the same thing. We are performing operations on 3 and 2. And now we are performing OR operation. So in case of bitwise OR operator, I will get output as 1 if any one value is 1. So here the thing is, uh, if both the values are 0, then only I will get output as 0. We all know that we are performing operations on binary level. So first compare this one, 0 for 0 and 0, I will get output as 0. For again 0 and 0, we will get output as 0. For 1 and 1, I will get output as 1. Similarly, for 1 and 0, I will get output as 1. Because if any one value is 1 means I will get output as 1. And I hope you can clearly understand it. It is a little bit confusing, but I'm representing this in a clear manner so that you can easily understand this. So we know that the decimal form of 0011 is 3. If I convert 0011 into decimal number, I will get output as 3. So here you can see here if I print A or B, then if I run this program, you can see here in the terminal, I got output as 3. In the terminal, I got output as 3. So now you know how I got output as 3. If any one value is 1, then I will get output as 1. If both the values are 0, then only I will get output as 0. Otherwise, I will get output as 1. So this is the thing about bitwise OR operator. Let me comment line number 19. And our next operator is bitwise NOT operator. So here, let me declare a new variable named x, and the value of x is 2. If I say not of x, so this bitwise operator is represented like this. So this key is present below the escape key. Below your escape key in your keyboard, you will find this symbol. So we need to use this symbol for performing not operation. So we know that let me convert two to binary numbers 0010. And here I am performing not operation. So I am performing not operation. We know that in not operation, if the number is zero, means the zero will become one and the one will become zero. This is how simply the not operator will work. So in case of bitwise and bitwise OR operator, we compare two variables. Whereas in case of bitwise not operator, we use only one variable. If I say not of x, then I will get output as -3 because the value which is over here 1101. If we convert this into a decimal number, then we will get output as -3. So this is the thing about bitwise not operator. So just remember these things, don't get confused. Uh, and to be frank, we are not going to use this concept anywhere. But it is better to learn. The next bitwise operator is XOR operator. So the XOR operator, it is represented like this. So you need to press shift plus 6. Shift plus 6. Let me mention that one also. Plus 6. If you press shift and the 6 key on your keyboard, then you will get this symbol. This is XOR operator. So I know that my value of A is 3 and the value of B is 2. Let me copy these things. And here I have converted 3 and 2 to binary numbers. And now I am performing XOR operation. So if I perform XOR operation, so I will get output as 1 only if both the bits are different. So here you can see both the bits are 0, 0. So I will get output as 0. For second one also I will get output as 0. For third one, 1, 1. Both the bits are same. So I will get output as 0. Here you can see finally 1, 0. Here both the bits are different. So I will get output as 1. Now if I print A XOR B, if I run this, you can see here I got output as 1. So of course, if we convert this number into the decimal number, if we convert 0011 to decimal number, I will get output as 1. So if you are not aware of binary numbers, then you will find it a little bit difficult to understand these operators. Because here in bitwise operators, the main thing is we are dealing with binary numbers. So you should be good at binary numbers. You should know how to convert decimal number to binary number and binary number to decimal number. So once you know those things, you will clearly understand these bitwise operators. So our next bitwise operator is left shift. Is represented with double less than symbol. So we need to use this double less than symbol to check to perform lift shift operation. So I have my variables A and B whose value are 3 and 2. Now here if I perform lift shift operation, then if so if I, in the line number 40 you can see I am going to perform A left shift B. So we know that the value of A is 3, which means 0011, and the value of B is 2, which means 0010. So here the thing is, if I perform left shift operation, then uh, here 3 left shift 2. So the value of 3 in binary number is 0011, and I need to shift 2 zeros to the left side. Let me comment line number 33. So around 11 people have raised their hand. I have enabled the chat section. If you have any issues, let me know. Okay, okay. This is the main issue with online classes. Everyone's saying that your screen is lagging, screen is stucking. I can understand from the last 15 minutes of videos. Like, I'm really sorry, guys. You have to face this issue. I don't know why this is happening. My internet connection is also good. Okay. Yes, it's a technical problem. Anyways, thank you for confirming. Okay, I can see that the screen is little bit lagging. Okay, I haven't explained the shift operator yet. I am going to explain it now. From our operator, it was stuck. Okay, okay. Okay, fine. Let us continue with our today's session. So you want me to explain about the OR operator, then I can quickly explain that. Here the thing is, if the value of both bits are 0, then only I will get output as 0. Otherwise, I will get output as 1. You can see here in the uh, end of here the end bits, which are 1 and 0. So here the both, here one bit is 1 and the other bit is 0. So I am getting output as 1. If any one bit is 1, then I will get output as 1. If both the bits are 1, then also I will get output as 1. I will get 0 only if both bits are 0. The main thing you need to remember is, if both bits are 0, then only I will get output as 0. Otherwise, I will get output as 1. Whereas in case of AND operator, if both bits are 1, then I will get output as 1. If any one bit is 0, then I will get output as 0. It is bitwise AND operator. Whereas in case of NOT operator, we convert zeros to ones and ones to zeros. It's the exact opposite. And we have seen that in XOR operator, if both the bits are different, which means you can see here in the end, here the first bit is 1 and the second bit is 0. Here both bits are different, so I got output as 1. Whereas in the third position, you can see both bits are 1, so both bits are same here, so I got output as 0. If both bits are same, then I will get output as 0. If both bits are different, which means 1 or 0, which means 0 or 1, here both bits are different, right? So in that case, I will get output as 1. So this is the thing about XOR operator. And now we are discussing about left shift operator. So once again, let me tell you this. So here, we will never use these bitwise operators. I have never used these things so far. So if you have any little bit confusion also, then don't have to worry about identity operators and bitwise operators. We personally never use them. So, but I just want you to learn these things because these are some of the basic concepts in Python. Okay, I hope you understood the point. So the remaining two bitwise operators are left shift and right shift. So this left shift operator will uh, push the zeros from left side to right side. So what does that mean exactly? Yes, if you, the time is 8:07 now. Just give me seconds. At least I need to make sure that you people are not facing any issues in my screen. Okay, fine, guys. It's all right. So after completion of bitwise operators, let us end today's session. So I need to explain one more operator here. So now we are discussing about left shift operator, right? So this left shift operator is mentioned like this. We need to use less than symbol 2 times. So in case of left shift operation, here I am saying 3 left shift 2. A left shift B means here the value of A is 3 and the B is 2. So 3 left shift 2 means I need to move two zeros from the left side to right side. So if I do like this, if I move two zeros from left side to right side, then my binary number will become 1100. So the decimal equivalent of 1100 is 12. So now if I run this program, then you can see here I got output as 12 because I here the main thing is I need to shift two zeros from left side to right side. So this is how the shift operator will work. This thing also perform operations on binary level only, but finally we will get output in decimal number. So this is the thing here. In case of left shift operator, we need to shift zeros from left side to right side. If I say A left shift B, which means 3 left shift 2, then I need to shift two zeros from left side to right side. If I do like that, then my 3, which is 0011, will become 1100 because I am shifting two zeros to the right side. So the decimal equivalent of 1100 is 12. So this is how left shift operator will work. And finally, we have the last bitwise operator, which is right shift operator. So this right shift operator is mentioned like this. We need to use greater than symbol two times. For right shift operator, we need to use greater than symbol two times. So here again, I'm going to copy these two things. And here, if I'm going to perform right shift operation, in case of right shift, if I say 3 right shift to print, 3 right shift to 2 or else A right shift to B, both are same because the value of A and B are 3 and 2. So here the binary value of 3 is 0011. Now here I need to shift, I need to delete last two bits. If there are any zeros in the right side, then I need to delete them. So here the thing is, if I explain this with 3, you will get a little bit confused. So let me change the number 3 to 8 here. So the decimal equivalent of 8 is 1000. Now I need to perform 8 right shift 2. So the binary form of 8 is 1000. So now I need to perform right shift operation on number 8. I am saying 8 right shift 2, which means I need to delete last two zeros from the number 8. So if I delete last two zeros, which means in other words, I am shifting that last two zeros to the front. So in left shift, I will shift from left to right. Here I have shifted these two zeros to right side. Whereas in case of right shift, I need to shift the zeros which are present on the right side to the left side. So here I have shifted the two zeros from right side to left side, and my number will become like this 0010. So the decimal equivalent of 0010 is 2. Now if I run this program, then you can see here I got output as 2 because 8 right shift 2 is 2 because 0010 is 2. So this is how the right shift operator will work. And these are the bitwise operators which are available in Python. You can check out this program file in GitHub page. I am going to share that link once again after completion of this session. And the thing is, yesterday we were discussing about assignment operators, right? There we need to discuss one more thing. So I will quickly explain that using this website here. So we know about equal to. This equal to operator is used to assign value to a variable. Similarly, we have plus equal to. So this will perform addition operation. After performing addition operation, it will assign the value to the variable. You can see here x plus equal to 3, which is also similar to x equal to x plus 6. So first addition of operation will be happened, and the result of that addition operation will be assigned to the variable. So this is how this assignment operators work. And the remaining assignment operators which we haven't discussed yesterday are these operators which are bitwise and equal to, bitwise are equal to, bitwise not equal to, left shift, right shift equal to, left shift equal to. We can see here, we mentioned this like this, x and equal to 3, which means this is also similar to x equal to x and 3. I will explain this with one example. Now here the value of A is 3 and the value of B be 2. So if I know that if I print A and B, then I will get output as 2 because you know how I got output as 2 because in case of AND operation, we will get output 2. You can check here in line number 11. So in case if I perform bitwise AND operation, I will get output as 2. Now here the thing is, if I say A and equal to B, now if I print the value of A, and you can see here, I will get output as 2. So what is happening here? I know that the value of A is 3, and I am performing bitwise AND operation here. A equal to A and B. So the value of what is the value of A and B? We know that the value of 3 and 2 is 2. So now the 2 is getting assigned to variable A. So while printing variable A, I got output as 2. So we know that this is the short form, which is a assignment operator bitwise and equal to. So this is how this assignment operator will work. I will get output as 2 because first I am performing bitwise operation on A and B, and I am assigning the result of A and B to variable A. So while printing the value of A, I got output as 2. So similarly, for you can check out for bitwise or equal to operator, not equal to operator, left shift operator, and right shift operator. The concept is same. We can see here also. You can check them. You can practice these things on your own. Now, these are the operators available in Python, and we still need to discuss about membership operators. So tomorrow, I think we are going to discuss about list tuples and sets. So tomorrow, let us discuss about all those things. After completion of that, we will discuss about membership operators. So today we have discussed about four types of operators: logical, identity, comparison, and bitwise. And I am going to repeat once again, we are not going to use bitwise operators anywhere. So if you have any difficulty in understanding, then let me know. I have enabled the chat section. And yes, this is the end of today's session. If you have any doubts, then let me know. I will clarify them. Okay, Sidhu says no doubt. Okay. Okay, Sunil Kumar Reddy in right shift operator. So here you can see here I am performing 8 right shift to 2. So what is happening here? The binary value of 8 is 1000. So I am performing 8 right shift to 2, which means I need to remove two zeros from the end of 8. So simply I need to delete these two zeros from the end of 8. So if I delete these two zeros, then my binary value will be 10. So what is the decimal equivalent of 10? It is 2. So whenever I print the line number 47, I will get output as 2. So we will delete the zeros which are at the end. Okay, Sinu says, no doubt. Okay, Sunil. Okay. So I will start the recording now. If you have any doubts, you can ask me now. I have stopped the recording.